Hi guys, welcome to Statistics with Mr. Robeson. Today we're going to take a look at experiment design. So first we're going to look at the difference between correlation and causation. Then we're going to take a look at observational studies. Then we'll introduce experiments. We'll go over the the variable types in experiments, and then the 4 principles of experiments. All right, so first up, correlation versus causation. This is a big area of mistakes often in statistics and just in general. All right, so correlation is when two variables are related. So like if one of them starts going up, the other one goes up. So if one increases, the other one increases. And if one decreases, the other one decreases as well. But this does not mean one of them is causing the other one to do something. They just happen to both be related. All right, it could just be chance. It could be that there's some other third variable that's causing both of them to go up or causing both of them to go down, but they are not directly causing each other to do anything. All right, an example here. So we've got the number of people who drowned from falling into a pool. That's the graph in red. Then we've got the number of films Nick Cage appeared in any given year. That's the graph in black. And if you look, these two line up very, very well. They're very well correlated, but Nick Cage appearing in movies is not causing people to fall into pools and drown, and vice versa, falling into pools and drowning is not causing Nick Cage to get work. All right, they just happen to be correlated. There is nothing causing one. Causation, on the other hand, which we find from experiments, is when one variable directly causes the other variable to change. So it's like one thing implies the other thing. To some degree. It might not be the only thing implying it, but it is implying it. All right, so an example here is smoking causes lung cancer. All right, we know that if you smoke, like you're taking in cancer-causing or carcinogens, and eventually you will probably get lung cancer. All right, so let's take a look at observational studies. So remember, in observational studies, no treatments are assigned. That's the big difference between observational studies is the assignment of treatments. Right? Observational studies, they just observe individuals, they measure variables of interest, but we do not try to influence the response, whereas in experiment, you do try to influence the response with the assigned treatments. Right? So with an observational study, you cannot determine a causal relationship. You can only determine if two things are correlated. So we can see if Nick Cage films and drowning deaths are correlated, but we cannot see if one's causing the other, which is exactly what's happening in that graph from before. Right? So examples of observational, all surveys are types of observational studies because we're not influencing anything, we're not assigning any treatments, we're just asking questions. Another one we went over was watching to see if people wash their hands in the bathroom. Again, you're just observing, you're not doing anything to cause them to do anything. And to see if smokers have different health problems from non-smokers, again, you're not assigning people to smoke, you're just seeing if there's a relationship there. All right, experiments, on the other hand, that's when we deliberately impose some treatment. All right, so the individuals in our experiments, those are they are experimental units. A treatment is a specific condition applied to the individuals in an experiment. And if we do an experiment right, if there's some sort of random assignment, we can determine a causal relationship. So we can get that two things are correlated, and we can kind of say, okay, one thing is definitely causing the other. We're not sure if other things are also causing it, but one thing is causing it for sure. So story time. When I was in 4th grade, we had a garden. It was a very small class. The guys had one section of the garden. The girls had another section of the garden. And we would kind of compete to see, who was doing better. So both groups would water their plants and pick the weeds and do other sort of gardening type things. And it was pretty much neck and neck. Then one of the other guys in class decided, hey, let's go out and get some Miracle-Gro, and we'll put Miracle-Gro on our plants. We won't let the girls know we're doing this, but we'll put Miracle-Gro on our plants, and we'll see if ours grow better. And sure enough, they did. Our plants grew a lot better. So that was a treatment. We added Miracle-Gro to our individuals, which were the plants, and the girls, I guess you could say they were the control group. They didn't know that, but they were. They were not adding anything extra. And we noticed that our plants grew more. So that was a causal relationship. The Miracle-Gro was causing the plants to grow more. All right, our variable types. So we mentioned these before. So our response variable is the response, the outcome of the study or the experiment. It's the y value. When you're thinking about x and y values, your response is your y value. It's your measured results. Response are your results. Your explanatory variable. That's what you think is explaining what's happening with the response. All right, it's predicting the response. That's your x value. The easy way to remember this is there's an x here in explanatory, and there's x value. It's the input. All right, so don't forget we also have other variable types. We've got quantitative that are numbers and categorical, which are labels or categories. So here's an example. Does age make someone more likely to vote a particular way? All right, so we'll take a look at this and we'll say, all right, well, what we're asking is, does age determine how someone votes? All right, so age is the input, so that's the explanatory. And voting, how they vote, is the response. So we're seeing if it makes a difference in how they vote. All right, what about race? All right, so in this case, our explanatory would be race. And again, our response would be how someone votes. All right, so we got input versus output. All right, some more examples. So the first one here, in a study conducted by the researchers at the University of Texas, people were asked about their social media use and satisfaction with their marriage. Of the heavy social media users, 32% thought seriously about leaving their spouse. Only 16% of the non-social media users had thought seriously about leaving their spouse. All right, so we got to figure out what's our explanatory variable, what's our input here. And what is the response? What's the output here? All right, so the input, what we're checking here, is social media use. All right, so we're not causing people to use social media. So by the way, this is an observational study. All right, the response from this observational study is if they had thought about leaving their spouse. All right, so it's really just like a yes or no. All right, if we move over here to the next one, and I switch colors because I want to mix things up. In a diet study using 100 overweight volunteers, 50 volunteers were randomly assigned to receive weight loss counseling, monthly weigh-ins, and a 3-month gym pass. Well, that's a pretty sweet deal. The other 50 were given financial incentives, earning $20 for losing 4 pounds in a month or paying $20 otherwise. Ooh. Along with the counseling, the weigh-ins, and the gym pass. So they're all getting those 3 things. All right. The group with the financial incentives lost 6.7 more pounds on average. All right, so here we are adding in this special treatment of earning money or having to pay money. So this guy, I'll put it up top here, is an experiment. Right, because we have this extra treatment of paying the $20 or winning $20. So the explanatory variable, or our x variable, right, so they're all getting the counseling, the weigh-ins, and the gym pass. So that's not varying from one group to the other. The thing that's varying is the money, the $20. All right, so either they're making it or they're paying it. So that's differing. The other group doesn't have that. So $20 versus no money incentive. And the response is going to be there. Let's see, the group in the financial incentive lost more pounds. So it's weight loss. So we're measuring how much weight they lose. All right. So the explanatory was the money, whether they were paying it or making it versus no money. There was no money involved in the other group, the control group, I guess you'd call it. And the response was the weight loss. So we're measuring how much weight they lost. All right, so experiment design. So we've tried to come up with words and phrases for this, but I haven't come up with anything better than CCRR. CCR was a band, I don't know, but CCR squared, CCRR, I don't know, I don't have anything. If you guys can come up with something good, let me know. So we have 4 things that we're going to do in any good experiment. So we're going to have some sort of comparison. So we're going to use a design that compares 2 or more treatments. So we are comparing treatments. We are going to have control. And I'm not talking about a control group. We're going to control for outside variables. So we're trying to keep outside variables the same for all groups. All right, we'll go over confounding variables or lurking variables. They're just another variable that could influence the outcome that we're not necessarily trying to measure. All right. Replicate. Each treatment on many units to reduce the chance of variation in the results. In other words, we want large sample sizes. Right? If we only have a sample of 10 people, that's generally not enough for an experiment. And finally, we want to randomly assign treatments. So assign treatments or assign experimental units to treatments randomly. So we could use a simple random sample, or some sort of other randomness, like flipping a coin, and like heads means you do this, tails means you do the other thing, but some sort of random assignment of treatments. So comparison, control, replicate, and randomize are our principles of experiment design. All right, so we'll take a look at one experiment here, and then we'll call it quits for today, and we'll look at some more experiment techniques in the next one. So cell phones and driving. So does talking on a hands-free cell phone. So now we're not even holding the phone to our head. We're using the hands-free, the Bluetooth. Is that making it more difficult to drive? So design an experiment to test if driving while using a hands-free phone affects the reaction time of college students. Use a driving simulator. So we're not actually going to drive them into things. So use a driving simulator and a hands-free phone to test the reaction time of drivers when the car in front of them suddenly brakes. On the driving simulator, use a sample of 200 people. Okay, so we've got a driving simulator. The car in front of you suddenly brakes. We probably want to check the reaction time. Yep, reaction time. All right, so here's where we're going to make our experiment. So we have 200 college students, and this is going to be an experiment diagram. So we're going to start off with a box here, and we're going to say we have 200 college students. Right? We want to break them into 2 groups some way randomly. Right? One way to do that is we could flip a coin, and heads they could be the hands-free phone driving, and tails they'd be no phone driving. That would work. That might not get us exact numbers in each group, but that'd be pretty close. Another way, we could use our simple random sample sombrero. And we could write, so there's my sombrero. And we could take a bunch of pieces of paper, and we could write, no phone on some of them, phone on some of them, and they could each pick a piece of paper out and then see which group they go into. And I think I'm going to go with that method. All right, so let's see, we're going to have the no phone group, and the size in this will be 100. And in the other group, we will have the other 100 people. I'm just going to call this the phone group. So, and we have to say how we're going to do this. So write phone on 100 pieces of paper. And no phone on 100. Put in a hat. Mix them up. Let participants select one paper. All right, then we're going to put in groups based on their paper. All right, yeah, a lot of writing there, but we gotta say how we're gonna randomly put people into groups somehow or another. We can't just write randomly. All right, and then we're gonna have them drive and measure the time. All right, and then these guys are gonna drive while on phone, the hands-free phone, and we're gonna measure the time there. And then finally, we're going to compare these two results. We're going to find like the average time for each and see which one is, if there is a difference. All right, so we've got, let's see, controlling for outside variables. I guess they're both doing the exact same thing, the same driving simulator. We've got a comparison. We're comparing results. So there's our CCs. Our R and R, we've randomly put them into groups. And our sample sizes, we had 200 people to start, 100 in each group. Our sample size is pretty good. So we've got our CCs and our RRs. All right, so that's what we just went over here today. Our next one, we're going to come back in with some more parts of experiment design. So there's lots of other things that can happen with experiment design. So that's what we're going to look at next. All right, I will see you later. Bye.